All right. It's Jessica Parcell again. We're in week 5 and we're just looking at some highly missed kind of problems or concepts that students have struggled with in the past. So I thought I would do a little micro lecture on a few of these. All right, let's pop in here. Permutations and combinations. So it says answer the questions below. All right, here's the first question. From the 13 albums released by a musician, the recording company wishes to release 8 in a box set. How many different box sets are possible? So first we have to ask ourselves if this is a permutation or if it's a combination. So if you remember permutation, the order matters. The order of things matter. With combination, you can change your order. You can change your order. So I always remember that by the CO on the combo. Tells me I can change my order and it's totally fine. Permutation sounds kind of permanent. So that means to me, in my mind, the order does matter. So if you think about this, this is a combination. They don't say that these albums have to be in any certain order. So we're going to go with a combination. All right, so the formula for combination is n factorial over r factorial and then n minus r factorial. Okay, so we have 13 albums. That's our n, and we're going to choose to release 8 of them in a box set. That's our r. Okay, so we have 13 factorial. And remember, as always, make sure to pause the video and then come back and check in with me. We'll see if we're on the same page. Okay, so 13 minus 8. We're going to change this to 13 factorial over 8 factorial 5 factorial. All right, so if you were to write this out, you're going to have, up top, you'll have like 13 times 12 times 11 times 10 times 9, times 8, dot, dot, dot. Down below, you would have 8 times 7 times 6 times 5 times 4, of course, dot, 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 dot. You'd also have 5 times 4 times 3 times 2 times 1. So we know this 8 up top and the 8 below, that's going to cancel all that out. So in your calculator, you'll be doing 13 times 12 times 11 times 10 times 9 up top. And in the bottom, you'll be doing 5 times 4 times 3 times 2 times 1. And that should end up with 1,287 ways that the recording company can release these 8 albums in a box set. Okay, an experiment involves 32 participants. From these, a group of 4 participants is to be tested under a specific condition. How many groups of 4 participants are possible? Again, this doesn't seem to be a permutation. They're not saying anything about any order, so we're going to go with a combination. So we know the combination is n factorial, r factorial, n minus r factorial. Okay, so we have 32 people. That's our n, and we're going to choose 4 people. That's our r. So again, remember to pause the video. Come back and see me. Okay, so we're going to end up with 32 factorial over 4 factorial 28. Let's see if I can make that a little nicer. Factorial. So when this is all said and done, right, you're going to have your 32, 31, 30, 29, 28. And I'm going to stop after that because down here you got 28 times 27 times 26. And we know, thankfully, that's going to all cancel. You're still going to have your 4 times 3 times 2 times 1 down here from this. So in your calculator, you're going to do 32 times 31 times 30 times 29. That'll be your numerator. And then 4 times 3 times 2 times 1 is going to be your denominator. And you're going to have 35,960. Those are possible groups of 4 participants chosen from a group of 32. All right, I'll see you back in the next video. Good luck on your test.